Okay, so we are in 9.2 for transforming quadratic functions. And so hopefully yesterday in the preview to today's lesson, you kind of saw what happens when I move some numbers around. I liked that lesson because it made you move stuff around and you got to see what did changing one number do versus changing a different number. And so hopefully you took your time with it and you went through it in a lot more details so you could see what happened, so it helps you out with this lesson. So today is really just reviewing what we had already done and how it applies. So the new vocabulary terms were transformation, translation, dilation, reflection, and vertex form. So specifically with all of these, transformation is when we keep the shape but change location or size. Okay, so a translation moves the function. So those are the ones that move us up or down or left or right. Dilation, which you did get to see a little bit, it changes the size. And you saw one or two of those towards the end. So reflections are the ones that make it go upside down. Okay. And so for quadratics, it's only the upside down reflection that we really see a big difference with. We don't really see it in the other formats. And then vertex form was the form you got to use all of yesterday. And so the standard form of a quadratic is the y equals ax squared plus bx plus c that we used all last week. And so this format would be y equals, I still have a, but all of the other variables went away when I use it. And so I had x minus h, and then it was squared plus k. Okay, so what this does is it goes through and it does use that information that I had before, but now it gives me some more information that I wasn't given before. So we'll be messing with a, h, and k in today's lesson, and we'll see how things kind of fall into place. So to get us started, first we're going to start with our vertical translations. And so these are the ones that if I add k, then it moved it up or down. And so it moves it up if k is positive, it moves it down if k was negative. So to see an example, okay, so with this one, if f of x is the blue one, g of x was added up 10 from f of x. And so it ended up, that is why it has, nope, not that screen. That's why this one has the plus 10 and f of x doesn't, and it's just plain old x squared. And so x squared is the parent function of, it's the most basic one, and then the other ones are the ones we get to mess with. And so with this one, k is going to be equal to 10, and so because of that, I moved my graph up 10 units. So in words, you can tell me that it translates up 10 units. So we just move up 10. So let's look at another one. And so in this case, what would k's value be in the function of h of x? And so that value is -8. And so because it's a -8, what direction should my function move? It should move down 8 units. So I translated down 8 units. I do want you in your homework using words like translate or dilate Those words are on our vocabulary list, so if you didn't get them, make sure you do get them as I roll through our slide. So, our next big concept is going to be using horizontal translation. So we already did vertical, now we need to talk about horizontal. And so for horizontal translations, notice that there is an H inside the square. And so it's the number inside the square that moves me left or right. And so in the formula, there is a minus H, but we need to keep that into consideration of, okay, is it minus, is it plus, which one do I use it? So when my H is positive, I move it to the right, but that means that this would look like an X minus 2. Okay, so this one would move, so that would need a square on it. So this would move oops, I'm erasing the wrong thing. And so in Word, this one would translate right 2. But if I had y equals x plus 7 squared, excuse me, so that one would translate left 7, okay, because the format was x minus h. So in order for this one to be x minus h, this one would need x minus negative 7 squared. Okay, so be careful with those signs when it tells you positive goes this way. So really, you're moving in the opposite direction of the sign that you see presently. So let's see how much you gained from yesterday, and take a moment and tell me, how does this translation go? Okay. So it should translate down 1, because my h is negative 1, therefore it moves left 1. So using math words, it translated left 1 unit. Okay, so similarly, we can use x minus 4 squared. And so with the, in this one, we're gonna, well, that one did not have an equal sign where it was supposed to. So there is supposed to be an equal sign in there. It's gonna disappear as soon as I hit the next part. But with it, h was 4, and so this one moves right 4 units. So it moves right 4 units. Therefore, it translates right 4 units. So let's use a couple of those things at the same time. So this one does have more than one thing happening. So for this particular problem, it is translated in 2 different directions. So first, my h would be negative 1 because it's inside, and my k would be positive 1 because it's the one on the outside. So that tells me that my function moves left 1 because h is negative 1, and then it moves up 1 unit. So putting that in math terms, I'm translated left 1 unit and up 1. So I'm going to give you another one that I want you to go and do on your own right quick. And so tell me, how does this one translate? So in this case, let's see if you got it. So h should have been positive 2, k should have been 6. And so because of that, this one translates right 2 units and up 6 units. So let's just keep going. With that, let's talk about dilations. So dilations change about how skinny or how wide it is. And so because of that, it does depend on two things. And we talked about this when we did our lines and when we did our absolute value functions that were in the shape of a V. So there are two different ways to do it. So if I have A on the outside of the square, or I could have written it with A on the inside of the square. And so that's going to make a little bit of a difference for us. And so give me 1 second. And so, or A could be on the inside. That does make a pretty big difference, so you have to pay attention. And so when it is on the outside of my square, okay, then when my number is bigger than 1, it vertically stretches, okay? Or when it's between the numbers 0 and 1, it's going to vertically compress it. But on the flip side of that, when it's on the inside, we have to deal with this whole 1 over A thing. Okay, so it's going to be compressed by a factor of 1 over A. Okay, so because of that, it switches things around. Okay, so in this case, when A is bigger than 1, it compresses it horizontally, and then when it's between it, it's going to stretch it. And so you want to be specific to use the right words depending on where it's located at. So with that, let's go and check some out and see how we can use them to our benefit. So to describe this dilation, well, first of all, I have to identify it. So is it on the outside or the inside of my function? So let's go check it out. Oops, one too many. Okay, so with that, it's in the form with A on the outside of the square. So then I just have to look at, well, 1/3. What's 1/3 set up as? Well, 1/3 is between the numbers 0 and 1, which means this one's going to compress it vertically because I have 1/3. Okay, so what this means in terms of the shape is it means it's going to be scrawnier than the other version. Oh, not scrawnier, it's going to be wider. So we like that. Sometimes we need it to be a wider function. But let's go and look at another version. Okay, so if we want to describe this dilation, which form is this one in? This one is in the form of the A on the inside of the square, okay? And so because of that, is this number bigger than 1 or less than 1? Okay, it is less than 1. No, bigger than 1, sorry. And so because of that, in this case, A is 2, and so 2 is going to be compressed horizontally, okay? So have these tables out, have it all pulled out, hopefully you've been taking notes. If not, rewind and start. And so this will all come into play and help us out a good bit when we're talking about what happens with this graph. So let's go. So this one is compressed horizontally. So last thing we have to talk about is reflections. And so if I have a negative in front of my A value, it reflects it. And so for these, let's go and look at one. So this one, A is -3. Oops, wrong thing. So A equaled -3. And we learned in our last section last week that when A is negative, it makes it go upside down, which gives it a maximum and makes my range need to be the Y is less than or equal to, and all those good things. So that -3 tells me I need to reflect, okay? So because it's negative, it is going to reflect it upside down. And it's going to reflect it vertically. And it gets stretched as well. So it gets a couple things. And so A is bigger than 1, so it gets stretched vertically. And then since A is negative, it reflects it across the x-axis. Okay. So what does that graph look like? Well, the graph of G is shown in green here, and F is in blue. So as a reminder, F of x was just x squared, and G of x was the one that got dilated with that -3, and it got stretched since they were both on the outside of x squared. Okay, so you'll use this idea of the dilations to try and talk about like sizes and which one's bigger and which one's smaller, and do they fit from widest to narrowest. So we're going to do one of those right quick, and then we're going to be done with this. So let's go in, and we're going to skip this one right quick. We're going to jump to the end. So part of your homework is going to ask you to compare multiple graphs together, okay? And so to compare them, okay, so f of x is the parent function, and so comparing it, let's talk about g of x first, okay? So g of x's equation is given to me in the form of the ax squared, okay? And so with this one, a is bigger than 1, so I get stretched vertically, okay? And then I need to identify the other pieces. So I have a is 4, h is -1, and k is 3. So putting all of those pieces together, I am going to be stretched vertically. I am also translated left 1 and up 3 units. So that lets me put all of those pieces together. So with that, I can also do it with my other function, okay? And so putting all the pieces together, I can identify that a is -2/3, h is +6, and k is 2. So with that, I'm going to be reflected across the x-axis, compressed vertically, and then I will also move or translate right 6 units and up 2 units. And so putting all of that together, I can combine it for these two. And so that's where I'm going to leave us today, is now that we've talked about those two. If you have any questions on your worksheet, come and visit me in my Zoom office hours on Wednesday morning. If you want to meet my new puppy, Bear, he will be with me in Zoom Wednesday morning during office hours. And so that gives you a chance to say hi to him. So let me know if you need anything. I'm here to help. You are not in this alone just because you're learning from a video. Ask me questions, shoot them to me in an email, ask me if we can set up a Zoom meeting. I'm here to help. I think that that's something that y'all haven't realized, because I'm not getting a lot of questions from freshmen. Ask me, I am here. Please don't Google answers on YouTube. Please don't. There's a lot of different levels of difficulty for quadratics, and a lot of them are higher than what y'all are at. And so we're finding a lot of videos that might technically work, but they're not answering the questions you need answered, which is why things didn't go so well last week. I saw a lot of you were using some really advanced techniques that didn't actually relate to what we were doing. So please ask me instead of using YouTube. I'm here. Have a great day, guys. Bye.